Welcome back to Datacraft Institute. In this video, we will understand what a database is, why companies use databases, and how tables, rows, and columns work. We will also do hands-on practice by creating a database and tables so you can see the concepts in action. This foundation is essential before we start writing SQL queries. What is a database? A database is simply a structured system used to store and manage data. Every app you use, be it banking application or streaming application, all store their data in a database. The goal of a database is to store information in an organized and reliable way, and then allow us to retrieve it quickly whenever we need it. So a database is structured system for storing and managing data, ensures security, consistency, and fast access, used in every industry, and handles huge volume of data. Why do we need databases? Spreadsheets like Excel are good for small data sets, but they break when the data becomes huge. Databases are designed to handle millions or even billions of records without slowing down. They also allow multiple users to access and update data at the same time, securely and efficiently. This is why every modern business depends on a database. So why do we need databases? It is centralized and structured data storage. Databases store data in an organized way, like in tables, rows, and columns. So information is not scattered across files and file system. Fast and reliable data access. Databases are built to quickly search, filter, and retrieve data, even when the data size grows very large. Data consistency and accuracy. They ensure everyone sees the same correct data by enforcing rules and preventing duplicate and conflicting informations. Multi-user access with security. Databases allow many users and applications to access data safely at the same time with proper permissions and controls. What are tables? In a database, data is stored inside tables. You can think of a table like a sheet in Excel, but much more powerful. Each table stores one type of information. For example, a customer table stores a customer details, an orders table stores order details, and so on. So to summarize, a table stores one type of entity. Example, customers, orders, employees, and products. Rows. A row represents one individual record inside a table. For example, in a customer table, one row represents one customer. In an orders table, one row represents one order. And every time a new transaction happens in a system, a new row gets added to a table. Columns. Columns represents the attributes of each records. Attributes means the characteristics. For a customer, columns may include email, age, or join date. For an order, columns may include order ID, amount. Each column has a data type, which ensures only valid data is stored, like text, numbers, dates, so on. So to summarize, columns is an attribute of each record, example a customer name or an order date, price or email ID, and each column has its own data type like numbers, text, etc. You can see here customer, products, employees, and orders are the tables of the database. Each table has columns like customer ID, product ID, employee ID. Okay. The tables are related by their primary keys. Now, what is a schema? A schema is like a folder inside the database. It organizes related tables together so the database is easy to manage. For example, a sales schema might contain customers and orders table. A finance schema might contain invoices and payments table. Schemas help maintain structure inside large databases. So, what is a schema? To summarize, a schema is a logical grouping of tables. Similar to folders inside the database, a schema will also have views and other structures. We are using only tables now for simplicity. Okay. It helps organize different business areas. Example, sales.customer. Sales is the database and customers is the schema. Again, here sales is the database, has a different schema called orders. Okay. HR is the database and employees is the schema. Now at the top, this is the logical structure of a database. Okay, a diagram to help you understand. At the top, we have the database, which is the overall container for all the data. Inside the database, data is organized in schemas, which acts like folders. Each schema has a table. For example, sales schema has customer table and orders table. Okay, and each table is made up of rows where each row represents one record. Row 1 customer, row 2 customer, and each columns ID, name, email is the attribute of the data, attribute of each row. Okay, similarly you have another schema for finance and there is another table for transactions table. Okay, so I hope the difference between rows and columns is clear. If not, you can comment. I will give you more examples. Now that we know how data is stored, SQL becomes the language used to interact with it. Using SQL, we can read data, filter data, insert, update and delete data, and build analytical insights on it. So SQL is the bridge between us and the data stored inside the database. Let us do some hands-on now. We will be creating our own database and then we will be creating a table and then we will be deleting the table and the database, and we will also be selecting the data from that table. In order to create your own database and table, you can go to this particular link. Okay, it is SQLLitebrowser.org, and then you have to select this particular installer, standard installer for Windows 64-bit version. If you are using an older Windows, you can use the 32-bit version, but generally we use the latest Windows, so we use the 64-bit version. And then click on whenever you click on this, a file will be downloaded, and then you have to click on install the file. So once you have downloaded the installer, you have to click on install and then you will get a pop-up like this. Click on next. Once completed, click on finish. So once you have downloaded and installed, you can click on DB browser SQLite and then you can just click on this icon. This will be opened. So now we will be creating our own database. Okay, so we will click on new database over here. So as soon as you click on new database, you will be getting a pop-up like this. Okay, so inside that pop-up you can give a database name. Okay, so my database name is DCI_DB. I will click on save. So if you want to see the database that you have created it, you can just open databases. And so after you click on open databases, you can see the database that you have created over here. The database is created with name DCIDB and the type is database file. So this is the database that we have created just now. And now we will be creating tables under this database and selecting from that table. After that, you have to click on create the table icon. As soon as you will click on create the table icon, you will be getting a pop-up like this. Here you can create your own table. So let us call it as student. Okay, and let us create one field called as ID. Okay, field name is ID. It's an integer. Okay, then name, it's a text. Sorry, not a blob, a text. And then age, again it's an integer. Okay, ID is a primary key. Okay, so after that we will click on OK. So our table will be created. So you can see a student has appeared over here. Okay, so a student has appeared over here. Now what you can do is you have to go to the execute SQL tab. Okay, and you can insert any values into this student. So this is an insert SQL. We will learn to write all these statements, but just for showing you, you can insert into students. This is the syntax: values, one for ID, this is in the order, and then Amit, and name for name, and 21 for age. So this particular line will execute only the current line. Okay, so there is some errors over here. So let us see what is the errors. No such table students. So our table name is student here, but we are inserting into students, so that is the error. Okay, so this is how you get an error and you see it and correct it. Okay, so again I will execute. If you see, the execution finished without errors. Okay, it's successful. And then in order to see what we have inserted, we will write a select statement. We will learn more about select statement in separate modules, but just to show you, we will write a select star from student. Okay, and you see it is giving me the recommendation as soon as I write something. We just press the tab button and the recommendations will be inserted in the current line, and then we will click on the execute current line. Okay, these are the values that we just inserted. Okay, so this is how you create a database. Okay, if you would see the your database files will be available wherever you have created it. Now let us delete whatever we have created. We will start with deleting the table student, and then we will see how we can delete the database in SQLite. There is a slight difference in the way we delete a database in SQLite and how we do in traditional data warehouses like Snowflake and other, like we use the drop statement. But here it is a little different. We will see that. For example, drop student. Okay, so this will drop the table student, but again it will give me an error. Let me see, is it giving me an error or not? Okay, so see, it is giving me an error because the syntax is drop table student. Okay, what you are dropping, is it a table or any other structure? Okay, student is dropped. Okay, and then you have to also drop the database. Okay, open database. So this is where the database file is created. Okay, this is the place where we initially selected and created the database file. You can see type is database file, and you can manually go and delete it, and this will delete your database. One more thing, if you want to drop a database, unlike in other SQLs, you cannot drop it from here. Like for example, your database name is, if you will see here, DCIDB. Okay, so you cannot drop it like this from SQL in SQLLite. Okay, so this will give you an error. Okay, so what you have to do is instead close the database. Okay, you don't have to make any changes. Then you have to come in your folder where you have the database created, database file, which is DCIDB. Then click, right click, and then you can delete it from here. Okay. So I hope you enjoyed the practicals and hands-on. So let's quickly recap whatever we learned. A database stores structured data. It stores data in the form of tables, rows, and columns. And schemas organize the data. And SQL is the language that connects everything. So thanks all. In the next video, we will understand the difference between OLTP systems and OLAP systems. So stay tuned.